So this is chapter 5, problem 2, where we figured out the age and the frequency of the mothers who were looking for birth control. Ages 18 to 19, there's 89 of them. Ages 20 to 24, there's 130 of them. 25 to 29, there's 66 of them. And 30 to 39, there's 26 of them. And if we found the sum of all of that, we would find that they would be 311 total of everyone. Okay? And so, when we look at this study, it also, the part of this question gave us some constraints about an A constraint, a B constraint, a C constraint, and a D constraint. Okay? And so the constraints were that the woman being picked at random is at least 25 years of age. And so if it's at least 25, that means it's 25 or more, right? So it's going to be the red and the green. So the 66 and the 26. In the B bubble, we're talking about the woman was at most 29 years of age. So when we're talking about at most 29, the oldest they can be is 29. That means they were in the red, blue, and black bubble. So 66, 130, and 89. C's constraint was that the woman is between 18 and 29 years old. Between 18 and 29 is again black, blue, and red. So it's the same bubble. So B and C are actually the same. And then D was that the woman is at least 20 years of age. So at least 20 means 20 or older. So it's the blue, the red, and the green was in the bubble. So 130, 66, and 26. So now that we know what each bubble is, and we color-coded that for A, B, C, and D, when they ask us a question, which the next part of the whole question was, what are the number of outcomes? What are the possible outcomes for a not D situation? For a not D situation. So when I do a poll, what's the probability I'm not going to get a D? And so what we would do is we would take and formulate that D bubble, and then anything that's not in D is outside of it. So we have this blue dot on the inside, green dot on the inside, red dot on the inside, and the black dot is on the outside. So not D would be represented by the black dot, because that's the only thing that's not in D. And so that would be 89. 89 is the frequency for not D. And so 89 out of the total will give us the probability of it occurring. So the total is 311, so we have 89 over 311. And when we look at the next one, it's B, and B says, what happens if it's B and D? So when we're looking at B and D, we're going to draw the B chart. So the B has a black dot, blue dot, red dot. And the D has a blue dot, red dot, green dot. And then when we take these two together and create this Venn diagram, we can see that the blue and red dot are in both B and D. So when we fill it up, we start with the B and the D circle, and then we look at B and go, is black in both? No. So it just goes here. Is blue in both? Yes. Is red in both? Yes. And that's all there is for B. So any other color for D is going to go outside of, it's going to be inside D's, but not inside of B's. Does that make sense? So then we can answer our question very simply. We know what's B and D by looking at the center. And the center is blue and red. So blue and red are 130 and 66. So we add 130 to 66 and we get 196. And that is 196 over 311. Okay? And then we can try to reduce that if need be. Then we look at C. C is where it gets confusing. Okay? C is where we have an inclusive or an exclusive OR. Because it says C or A. And you have to know, is it going to be inclusive or exclusive? And the book states that all these problems, they're going to be focusing at exclusive ORs. But let's talk about the difference between an exclusive and an inclusive OR. Okay? So this is where we were talking about the exclusive OR is kind of like if you have a divorced couple and they have a child. And this couple does not get along. So they don't want to do things together. So they tell the child that the child has a choice. They can go to Disneyland with mom or with dad, but not both. And that's being an exclusive OR. And then if you look at a different couple that maybe get along and will do things together, then they will choose to use what's called an inclusive OR, where they will say to their child, we'll take you to Disneyland. You can go to Disneyland with mom or with dad or both. So the or mom or dad kind of includes mom or dad or both. So it's not excluding anyone. Okay? So when we look at an exclusive OR, when it says C or A exclusively, then we look at C, and C's bubble has a black, blue, and red, and A's bubble has a green and red. And the one thing we notice is that the red is in both A and C. So if we're talking about an exclusive OR, we cannot include, we do not include what's in both. Only what's in C or A, and that's it. And so what's in C or A is just black, blue, and green. 89 plus 130 plus 26, which is 245, and we come up with the conclusion of 245 over 311. If we were to think of it as inclusive, all four are there. So therefore, it would be 311 over 311. Okay? And then the last problem, I decided to erase so we could at least do one problem together for the fourth time, is D. And D, it's set up as A and B. And remember, we're using our symbolic logic. So the symbols of the dot is and. The symbol of the squiggly line is a not D. A and B. And then you have the V over here, which is C or A. Okay? And so when we talk about A and B, we just set it up. We have a bubble for A. We have a bubble for B. And then we'll start with the one that's smallest. It's always easiest to start with the one that's smallest. So A is the smallest. And so we'll start with A, and A has red. Does B have red? Yes. So that dot's going to go in the center. A has green. Does B have green? No. So that goes over here. And then obviously anything else B has, A does not have, right? So B has black, and B has blue. Okay? So between the two of them, they have all four. But when we say A and B, we mean what's in both of them. Okay? So when we look at that, we're saying A and B. So we're not saying the combination of the two. We're saying what's in both A and B. Just like when we talk about or. We're not saying what's in C or A. We're saying what's not in both. See what I mean? There are two opposites. Okay? And so what's in A and B is the red, or the 66. So we got 66 over 311 is going to be our probability of getting something that's in A and it's in B. Okay? Or picking a woman randomly will be a 66 out of 311 will be the chance of us picking a woman randomly that's in A and B situation. Does that make sense? Okay? So, again, I want to reiterate that this can be simplified if the organization skills are there. And one of the key things to organizing with this is the color coding of your age groups. So when you create your bubbles, you can use colors for dots instead of numbers. When you plug numbers in there, it can look a little bit too chaotic. Too many numbers together. You don't know if it's 66 or if it's 896 or you see what I mean? But by using those dots, it's simple. I see blue, green, red. I don't see black, therefore not D would be black. D would be blue, green, and red. Okay? And then you just look up here to blue, green, and red and add them up. And that's problem 2.